Now, what is going to be our R is determined by what the pressure is. So what is the pressure? The pressure is measured in Pascal. When the pressure is measured in Pascal or Newton per meter square, the R is going to be 8.314. Hello and welcome back to my channel. Today we have an exciting topic to discuss on ideal gas equation. Basically, we know that there are four quantities that are necessary for gases, and these include pressure, volume, moles, temperature. These are the four quantities necessary for gases. However, the ideal gas equation is written as PV is equals to nRT, where P is for pressure, V volume, N number of moles, R is a constant, and T is temperature measured in Kelvin. Now let's look at R. Making R subject of the formula, you have PV over NT. So when P is 1 atm, P is measured in atm times volume is 22.4 dm cube, all over number of mole. We are taking that of 1 mole of a gas. 1 mole times temperature is 273 Kelvin. So we are going to cancel out. Unfortunately, there is none to cancel out, and we are going to divide 22 divided by 273. That is going to give us 0.082 atm dm cube per mole per Kelvin. So this is how we arrived at R equals to 0.082 atm dm cube per mole per Kelvin. So take note of the pressure. The pressure here is in atm. So when you are solving solutions and the pressure is in atm, you have to use this R. You have to use this constant. But when you are solving solution and the pressure is in Newton per meter square or in Pascal, we know that 1 Newton per meter square is equal to 1 Pascal. So what will it be? So let's look at R at 1 mole of a gas. That will be R is equal to, now this pressure is 1.01 times 10 raised to power 5. So this is going to be, pressure here is going to be 1.01 times 10 raised to power 5 Newton per meter square times volume. Volume is 22.4 dm cube divided by, we have our number of mole. We are looking at 1 mole of gas times temperature is 273 Kelvin. Now there is none to cancel out, so if we multiply this by this and divide by this, we are going to get 8.314. However, the 8.314 is converted, this is Newton per meter square, is converted to Joule. We know that work done in gas is PV. And this PV is Newton per meter square times dm cube, or Pascal times dm cube. So 8.314 Joule per mole and per Kelvin. Please don't forget that work done in gases is PV. So work done is energy. Work done is energy, and energy is measured in Joule. But this is only attainable when your pressure is measured in Newton per meter square or in Pascal. Otherwise, when it is measured in atm, you have to use this R. So please take note of these differences. The next time you're going to use this R is when you are doing solvings that involve energy, like in entropy and other energy stuff. Alright, so this means that if you are solving an ideal gas equation and your pressure was given in millimeter mercury, that means you're going to convert. If it was given in torr, you are going to convert. You are going to convert to atm in order to get your answer. Now let's solve some practice questions. Okay, so let's look at this practice question. You have that a gas occupies 0.5 dm cube of 2 atm at 10 degrees Celsius. Calculate the number of moles present. So first thing we need to do is to write out our parameters. So what are parameters? You have this to be what? Volume, 0.5 dm cube. You have 2 atm to be pressure, 2 atm. And you have 10 degrees Celsius to be temperature. Now we are going to convert to Kelvin temperature by adding 273 since it is in degrees Celsius. And that is going to give us 283 Kelvin. Now, take note, our pressure is in what? ATM. So there is no need to do any conversion. We are solving straight. Using the general gas equation, you have PV is equal to nRT. So what are we looking for? We are looking for the number of moles. So this is N, number of moles. We are going to make N subject of the formula, and that will be PV over RT. So P is 2 times volume is 0.5 all over. Our constant here is going to be what? 0.082 times temperature is 283. So we are going to punch our calculator to get our answer. So you have that 2 times 0.5. That's going to give us 1 over 0.082 times 283. That's going to give us 23.206. So 1 divided by 23.206, that's going to give us 0.0431. So this is the number of moles given. Then if you are to convert your answer to standard form, that would be 4 times 4.31 times 10 raised to power. Since it began with 0, it's going to be minus. Then you count the number of zeros, minus 2 moles. Answer. Isn't that simple? Let's look at another practice question. Okay, so let's look at the second practice question. 2 moles of a gas at a temperature of minus 13 degrees Celsius and a pressure of 725 millimeter mercury has a volume of. So we are looking for volume. Now let's look at it. Writing out the parameters, you have number of moles to be 2 moles at a temperature of, the temperature is minus 13 degrees Celsius. You are going to add 273 to convert to Kelvin, and that's going to give us 0.62 Kelvin. Then you have a pressure of 725 millimeter mercury. 725 millimeter mercury. Now the pressure here is in millimeter mercury, so you are going to convert millimeter mercury to atm before you do your solving. So how do we convert that? 1 atm is equal to 760 millimeter mercury, and 725 millimeter mercury, you are going to be writing it at where they are, will now give you how many? So it's going to be 725 times 1, you're going to cross multiply, 725 times 1 divided by 760. So let's punch our calculator and get our answer. 725 divided by 760. That's going to give us 0.954 atm. With this, we can now solve using the ideal gas equation. PV is equal to nRT. So we are looking for what? The volume. We are looking for V. So this is going to be V is equal to nRT all over P. So N is given as 2. N is given as 2 times R. What is going to be our R? 0. Because it's in atm. 0.082. Then temperature is 260 all over. Pressure is now 0.954. I hope we are following. So we are going to punch our calculator, and that's going to be 2 times 0.082 times 260, and that's going to give us 42.64 all over 0.954. So divide this by 0.954, divided by 0.954. So that's going to be 44.696. Now let's approximate this to the nearest whole number. That would be approximately 45 dm cube answer. Remember, our R is in what? dm cube. Remember. Now let's look at another practice question. Okay, so let's look at this practice question. A gas occupies 250 cm cube at 76512 Pascal with a temperature of 16 degrees Celsius. Find the moles. Now, the first thing to do is to write out our parameters. So you have this to be volume. Volume is 250 cm cube. But wait, this is in cm cube. Remember, our R is always in dm cube. So we're going to convert this volume to dm cube by dividing by 1000. And when we do so, we now have our volume to be 0.25 dm cube. Remember, if this is given in liters, liters and dm cube are the same. Okay, then we also have our pressure to be 76512 Pascal. And we have our temperature to be 16 degrees Celsius plus 273 to convert to Kelvin. And that's going to give us 6 plus this is 9. Plus this is another 8 and this Kelvin. So we have 289 Kelvin. Now, using the ideal gas equation, PV is equal to nRT, we are looking for moles. So N. Let's make N subject of the formula. That will be PV over RT. Now, what is going to be our R is determined by what the pressure is. So what is the pressure? The pressure is measured in Pascal. Remember, at the beginning of the class, I told us when the pressure is measured in Pascal or Newton per meter square, the R is going to be 8.314. Okay, so let's solve. We have our N to be N is equal to pressure is 76512 times volume is 0.25 dm cube all over, this is R is going to be 8.314 times temperature is 289. So it is time to punch our calculator to get our answers because the figures are numerous. So you have 76512 times 0.25. This gave us 19,128 divided by, you have 8.314 times 289, you have 2,402.746. So we are going to divide. So let's divide 19128 divided by 2402.746, and that's going to give us 7.96089. So let's leave our answer in the nearest whole number. That's going to give us 8 moles. Remember, we are looking for number of moles. Isn't that simple? All right. Thank you for watching. I hope you find value in this video. Please do well to subscribe to our channel to enable us to do more.